Okay, so today we're going to be covering the 1.8 material regarding the mean, median, and mode. So a lot of this is some fairly introductory stuff to the general idea and concept of statistics. Can and will have more methods and tools that we're going to use with statistics later on, but for now this is the one that we are going to be starting with and working with for this quarter and for a little bit of time. So first and foremost, we're going to start with some core vocabulary, and then we're going to go into each of these specific concepts on a more individual basis. And we'll go through some of these as examples as well. And I'll show you guys a few ways you can organize these for yourself and write them out, because organization is pretty important for these ones. So our main definitions that we have here, we have the mean, which is one of the main ones that we're going to be working through, and that's the average of a set of numbers. So within this entire section, we're going to end up starting with, okay, here's a set of 5, 10, 15, 20 some odd, however many numbers or set of data that we are going to be working with. And we get to do all these different operations or calculations regarding that set of numbers. So again, our mean is our average of all of that, that set of numbers that we have been given. And we'll go through how to calculate that here in a second. If you know how to calculate an averages, great, you're ahead of the curve there. If you don't, that's fine. We're going to go through it here in a second. So we also have the maximum, which is the largest value in the set of numbers that we have. We have the minimum, which is the lowest. Again, two pretty straightforward ones, which is nice. We have the median, which is the value in the middle of the set. When we are working with finding the median, and we'll go into this in more detail here in a little bit, the set of data must be arranged from smallest to largest to determine the median. If we are working with this and you do not rearrange the data, you will get wrong answers and you'll lose points. And we don't want that happening. Okay, so median is arguably the most picky of all of these that we're going to go through. The mode is the value or the number that appears the most often in the set of data. And that is, again, just if I look at all of this, maybe I have 3 10s showing up and everything else just shows up at once. It's just what has the greatest frequency of showing up in the set of data. That's the way of looking at it. And then our last one that we have is the range. And that's the maximum value subtracted by the minimum value. So what's the range of data that I'm working with overall? It's a general concept with that. And the range is a pretty straightforward one to calculate once we have the maximum and minimum value. I think we could probably just in our head do kind of generalize what this is going to look like just based on the description of what we're doing with it here. But again, we'll go through a couple examples with these accordingly. So we'll start off with looking at the mean itself. So I'm going to zoom us in here a little bit. Hopefully zoom us in here a little bit. There we go. So our process to determine the mean. I have, again, we're given a set of data. It could have, 1 or 2 values in it. It could have 10. It could have 15 sets of numbers that we don't really necessarily know. But the process is going to be the exact same regardless of how much information we've been given. So our process with this, first and foremost, we're going to add all of the numbers in the given set together. So you're just using your calculator if you want to do that. You could use, but you could do it by hand. A couple ways you can organize that for yourself, and we'll go through an example down here with it in a second. So I add all of the numbers in the given set. After I do that, I'm going to divide that sum by the amount of numbers that I had in the set. Just a little bit weird in the wording on it, but I want to clarify that. So we're saying, how many pieces of information do I have in the starting set of data that I've been given? Well, let's say we have 10 numbers. I'm going to add those 10 numbers together. I'm going to get some result, whatever that may be. And I'm going to divide that result by 10 because that's the amount of numbers or amount of elements, the way you could look at it, that I have in the original set of data. So I'm going to go through and, yeah, we have the example here, but I'm going to go through and write this out just for the sake of seeing how we could organize this in our work. I think it's worth seeing one way of organizing it at least once. So find the mean, the set of values 10, 8, 3, 5, and 10. Okay? So I'm going to jump us over to the whiteboard here. So referencing that same example that we just had, we started with, we're told to find the mean. There are numbers that we had here, so I'm just relisting what we had from the previous page. So we had 10, 8, 3, 5, and 10. Okay. So there's a couple ways that you can organize this for yourself, and I think regardless of whichever one you choose, you want to determine, if nothing else, how many elements or how many numbers we have in this set of data. I'm going to make this 3 a bit better. So as we're looking at this, we're seeing that we've got 1, 2, 3, 4, 5 numbers in this set. Okay. So I have a couple ways you can organize. I like writing this out as number of elements for me. So I have 5 elements in this set. Okay. So we're going to be adding these numbers together. So I have 10 plus 8, oops, plus, there we go. So again, our first step was just to add these numbers together. We'll get an answer. So when we do add those together, we're going to get 36. Okay. Our second step was to divide that sum by the amount of numbers in the set. So essentially our number of elements that we just found right here. Okay. So I'm taking that 36 and I'm dividing it by the number of elements that we found. So 36 divided by 5, you can use your calculator. Help out with that, and we're going to get 7.2 as our final answer. So what is the mean of 10, 8, 3, 5, and 10? It's going to be 7.2. Okay. Now another way you can organize this, and I think this is really a nice way of doing it if we use PEMDAS in our order of operations appropriately, is we set this thing up as a fraction. I know a couple of you are hearing, oh, it's a fraction, one of the F words of math. Trust me, embrace the fraction. It's fantastic. It's really helpful for these. Instead of having to keep track of 2 different things that we're doing, we can kind of condense it down to one big problem there. So just another way you can write it. So there's an alternative method. You don't need to do this if you don't want to. But again, I'm writing out the sum of everything, some of the elements being added together. And then I know that entire thing is going to be divided by the number of elements in that set, which is 5. And then if you wanted to, you could put parentheses around the numerator, optionally. And then from here, now we're applying PEMDAS. We'd say I want to simplify the numerator. It's going to give me 36. The denominator stays as 5. 36 divided by 5 is 7.2. You can apply your calculator for that as necessary, and you get your answer. So 2 ways of going about solving for the mean, 2 ways of organizing that for yourself. I do not care which one you guys would like to use. It's your call. I just want to give you guys a couple ways of going through and organizing your works. I think that's worth seeing. Because I know some people like organizing things a little bit differently than others, which is fine. Whatever works best for you. Okay. So we're going to jump back to our notes and move on to taking a look at the median here. So the median is the pickiest of all of these, and I think it has the most work that goes into it in that regard. So for the median, this guy here, our process, and this is one that you absolutely must do this step. I think I could sit here and put a bunch of stars next to it. I'm going to put some of the other types of stars right around this thing. You absolutely have to arrange all of the values in the given set from largest to smallest, or lowest to largest, I should say, when you're going through this. If you do not do this first step and you're solving for the median, I guarantee you are going to get wrong answers. There's no way around it. You cannot avoid doing that step at all. So again, I can't emphasize that enough, but I don't want to make a mess of the page that we have here. So you absolutely need to make sure that you are doing that first step, because if not, everything else with this is going to fall apart. Okay? So once we've done that, again, we are looking for the number in the very middle of the set. So find the value that is directly in the middle of the set of numbers. There are two ways you can do this. And for the most part, we're just going to be counting in from the sides. So we have two possibilities that could come out of this. There is a single definitive number in the middle of the set. Bam, we have our answer. It's the median. It's right there, ready to go for us. The alternative, and this does happen, it's not uncommon for this to happen either, if there are two numbers in the middle of the set, meaning as I'm counting in from both sides of the rearranged set of data, when I get to the middle, I find two numbers there. Well, the median is a single number, so the only way I can find the median then is to find the mean of those two numbers. And again, the mean is finding that average, just like we did up here. Okay. So always, always, always rearrange the data from lowest to largest. Then we're just counting in from the outsides into the middle. If it's a single number in the middle, great, we're done. If there's two numbers in the middle, we need to find the mean between them, and then we're done. Okay. So we're going to go through each of these two examples here again, just to see each of these scenarios. So I'm going to go back over to the whiteboard, but these are the two examples that we're going to reference over there. Okay. So our first one that we had, so our first example had us working with 5, 19, 10, 13, 8, and 11. Okay. So again, I'm told I'm finding the median of this set of data. So before I do any calculations of any kind, I need to rearrange this for myself. You don't do that, you're losing points. There's no way around it. I think I had, in the years that I've been teaching this, I think I had a fair amount of people not do that and just guess. And I think I've only ever had someone once guess the correct answer. And when I asked them about it, they're like, well, how did you get this answer? I don't know. I don't even know if that's right or not. So don't roll the dice on that front. Absolutely rearrange these things. So we're rearranging this lowest to largest. So we're just going with 5, 8, 10, 11, 13, and 19. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I've got everything the same number of elements there. Looks a bit better looking. There we go. Okay. So now, again, I'm finding the median. I'm just finding the number in the middle. So starting from the outsides, so use a different color here, use blue. So from the outsides, going in 1, going in 2, going in 3. Okay, so I do not have a single number in the middle. I have two numbers in the middle. So following our process, if there are two numbers in the middle of the set, find the mean of those two numbers. Okay, well, we just went through finding the mean with that. So I'm finding the average. So I'm going to add those things together and then divide by the number of elements in the set. So here I'm just working with two numbers. Adding those together, I'm getting 21 over 2, and then I'm getting 10.5. So what is the median to this set of data? It's going to be 10.5. Okay. So that was our first example that we had there. Take a look at our second example. Again, just referencing the numbers from that other page, or from our notes, I should say. So we have 7, 11, 4, 8, and 2. Okay. And again, first things first, we've got to rearrange this thing. And lowest to largest, so we've got 2, 4, 7, 8, and 11. Okay. And then we're just counting in on the side, so I'm going 1 in, 2 in, oops, there, and middle number here. So fantastic, we've got it right there in the center for us. So our median is going to just be 7. We have our answer there. Okay. So again, the median is it's a fairly straightforward one once we rearrange everything at the very beginning. But if we don't do that step, again, I cannot emphasize this enough, and you guys might be saying, oh my gosh, Alex, just stop saying that over and over again. I emphasize that only because I can only say it so much, and I know it's going to show up. People will not do that on the test. So I'm trying to do everything in my power to make that as abundantly clear as possible that it needs to be done. Okay. All right, jumping back to the notes here. We're going to take a look at the mode. So the mode, so we're working with this one here. Our process for this, again, the mode is the number that appears most frequently in a set of data. Now, the process to find the mode. The first step, it's recommended, arrange the values of the given set of data from lowest to largest. I highly recommend that you do this first step. It is not absolutely required, though. I think this rearrangement makes it a heck of a lot easier to actually see what repeats more often than anything else, but you could do it without that. I just think it makes life a heck of a lot more painful to make that happen. Once you've done that, just determine which number repeats the most, and there's the mode. There's not much to it beyond that. So we went through a couple examples of, given a set, how to rearrange it. So we're just going to walk through our two that we have here, because the mode does not have too much, if anything, in the way of calculations. So we're going to work with our first example. So we're given a set of 5, 8, 3, 5, 10, 12, 1. And you might be able to look at this right here now and say, well, it's going to be 5. It repeats twice. Okay, well, cool. Let's go through the process. Rearrange this thing. So rearrange it from lowest to largest. And again, the nice part that I find with rearranging this, now it's even more clear what shows up the most. So we have 5 showing up 2 times. Everything else just shows up once. So the mode of this set of data is 5. Again, I think rearranging it makes it a heck of a lot easier to see that. Okay. Taking a look at our other example that we have here, we're given the set 8, 7, 1, 10, 11, 7, 1, 12, 7. Okay, so there's a couple of things that repeated a few times in there, which is fine. We rearrange it, again, lowest to largest. And I'm getting 1, 1, 7, 7, 7, 8, 10, 11, 12. So I have 1 that repeats 2 times, and I have 7 that repeats 3 times. And that is the most in this set of data, which means that the mode for this overall set is going to be 7. Okay. Now, as we are going through these, this is a question that comes up fairly frequently. It's very understandable, and it's a good one to ask. Maybe this is you that's having that question. Can I have multiple modes in a single problem? And yes, you can. Let's say in this one, for instance, we had an additional 1 that showed up in this problem. So I had 3 1s and I had 3 7s. Well, the mode would then be 1 and 7, and you would just list both of those out. So for modes, we can absolutely have multiple answers to it if the original set of data does have multiple numbers that repeat the same amount of time. So multiple answers for mode is perfectly reasonable. There's nothing wrong with it. Just make sure that we have everything written down and that frequency determined accurately for ourselves. Okay? And again, I think rearranging it, doing that first step, makes this calculation, this computation a heck of a lot easier to do. So rearranging that goes a long way with this one. Again, not required, highly recommended though. Okay. So move on to our next part. Okay, that's 2.1. Come over here. And we're going to look at our range. And again, the range is one. We got a process for this. It's using some of our previous definitions that we have, but the range is our last one that we're going to go through here. So our process for this, again, first and foremost, arrange the values of the given set from lowest to largest. It is not absolutely required for the range, but again, highly recommended that you do it because it makes our second step here a heck of a lot easier. Determine the maximum and minimum values. I think that's really easy to do if you have your numbers arranged from largest to smallest or smallest to largest. Just a thought. So once we've identified the maximum value and the minimum value, subtract the minimum value from the maximum value, and that result is the range for that set of data. Okay. So we'll work with our example here. Again, there's not a whole lot in the way of computation with this. It's a lot of just reorganizing. We're told to determine the range of the values 10, 19, 9, 14, 11, 13, 8, 11. Okay. So again, we're going to rearrange this thing, lowest to largest. Just did that here. Determine the maximum and minimum values. And when you are going through this, I would highly recommend you write out for yourself max is, or max equals 19, minimum or min equals 8. Just write that out for yourself somewhere on your paper, because it's amazing how many people correctly identify it and then will actually do the calculation with different numbers. So again, that organization is key. These. Okay. So we've determined the maximum, we've determined the minimum. Step 3 says subtract the minimum value from the maximum value. Well, okay. So I've got 19 as the maximum. I'm subtracting 8 from it. I'm getting 11. So the range of this set of data is 11. Okay. There's a fair amount of these problems that show up where they might be giving you a single set of data, but they'll say determine the mean, median, range, mode, maximum. They might ask you to solve for everything at once, or go through and solve for all of these different things with a problem, which is fine. But again, I'm going to recommend if the median is showing up in there, just rearrange everything at the very beginning. Keep that work organized from yourself. We just saw that the range has us rearrange these things because it helps. The mode has us rearrange these things because it helps. The median demands that we do that. So for 3 of our 4 calculations that we're doing, rearranging is going to be useful. So again, I would start with doing that with all these problems. Okay. Now I'm going to go through, here's our more of the rationale as to why we go through this process, which I think is really nice to see. The larger picture, as it were, of all this. So the idea behind why we go through these, again, it's related back to statistics. And a lot of it is trying to find or determine what is the best average for a set of data. And right now, I don't know if anyone has or is looking into any of the data that's coming out about the coronavirus and everything, but this is a very interesting time from the standpoint of data collection, how data is being monitored, tracked, and analyzed. And a fair amount of this is stuff that on some way, shape, or form is being used in those data analysis processes. Sort of like, for instance, you might say, what's the best average time for maybe until symptoms appear or something else like that? This is actually used in a lot of medical research as well. They have some other more advanced models and calculations that they do, but a lot of it stems and starts from what we're learning here today. So the idea of trying to find the best average for a set of data, and best is sadly a very subjective term with some of these. We call the process for determining that the measure of central tendency. It's a big fancy way of saying, I'm going to do all these calculations and then just figure out which one is the best for what I'm working with. Okay? So again, our general idea with this, we're going to compare all the previously discussed calculations, so the mean, median, mode, range, all of that, to find the most accurate average for a set of data, or set of values that we have. When we're doing this, the mean is generally a good place to start, but I would be very cautious with saying, well, the mean is going to be the best average, because mean it means the same thing as average. I'm looking for the best average. I should just go with that and find the answer. And sometimes it's a great place to start, but it's not always going to be the best average for a set. The main reason because that is because extremely large or extremely small numbers can skew a mean, and these are referred to as outliers. So let's say, for instance, we have, I'm trying to think of a less gruesome example than the stuff that's going on. If we're trying to determine, let's say, average scores on a test, the best average for a set of 10 scores on a test. And if I'm looking at student scores, because no one's taken a test, this isn't representative of anybody. Let's say 9 of those 10 scores are all in the 80s, between 80 and 89. Okay? And then one person's score is 30%, so down in 30. So that outlier, if we go through and we calculate that thing, is going to give us issues. It's going to skew that average because it's so far out and different from the rest of the data that we have there. And we'll see a bit more of that when we calculate it in this example. But it's what is so far away from the rest of the chunk of the data that we have there. How does that affect things? And the mean is the one that is most affected by that. Okay? So we'll take a look at an example that we have here. So we're told determine the best average for the set 10, 11, 9, 13, 11, 15, 155. So if we're determining that, we're going to need to find the median. So at some point in time, we're going to need to rearrange this thing. So let's just start with doing that. So that's our first thing that we did here. So let's determine the mean first. So again, I'm just adding all of these elements together. So I've got 1, 2, 3, 4, 5, 6, 7 elements. So I'm adding them all together and dividing by 7, because that's how many elements I have. So I'm finding that the mean for this set of data is 32. Okay? Got a couple others that we need to calculate, but that's fine. So I'm looking at the median. And again, I'm counting in from the side. So I've got 1 in from the sides, second one in, third one in, and I have an 11 sitting here in the middle. So my median is going to be 11. Looking for the mode, what number appears the most frequently in this set of data? Well, 11 shows up twice. Everything else just shows up once. So the mode also has to be 11. And then I'm finding the range. So it's the maximum value minus the minimum value. So my maximum of 155, and I don't know why that's written in incorrectly. That's horrifically wrong. That should be 155 minus 9. And we get, what's that going to be? Mental math. 146, I want to say. If my mental math is correct. Let's just rewrite that in here now, because that should be 155, and that should be 146. Okay. So a couple errors on my part there, but hopefully this should fix that up there for us. So we have our mean, median, mode, and our range. So what is the best average for the set of data? Well, comparing all of these, 146, not going to be that great, because a good chunk of these are all between 9 and 15, and this thing is way, way beyond that. So range isn't going to work well because it's way too skewed. If I look at the mean, okay, it's a bit closer to the set of data, but most of these are between 9 and 15. That's up in the 30s. And then this outlier out here, this is way up at 155. It's way, way, way separated from the mean here. So the mean, not going to be a good average for this. We're looking at the median and the mode saying 11. Well, Yeah, it's looking kind of close, kind of in the middle of all these things if you take this outlier out of the set. So based on what we have here, the median and the mode are going to be the best average for this. And this is where the analysis part comes in of how do we define, how do we determine best, maybe best in the context of a different type of question that we're being asked could be better. This is generally what shows up in a lot of story problems is determine what's the best average to use for finding a solution to something over anything else. Okay? So sadly, it's a fairly subjective portion that shows up on these homework assignments and whatnot, but I think it's worth seeing and going through at least once or twice because if you are someone who's going to go on to do more statistics in the future or continue on with math as a generality, you're going to need to be doing numerical analysis, some data analysis as well, especially in statistics. There's tons of data analysis in there. And it's really interesting stuff, but this is where it all begins, essentially. Okay. So that is everything for the 1.8 material. And I don't really think there's too much on it at face value in terms of the calculations. That's particularly grueling. And I'll say it again, it's the last time, I promise. Highly recommend rearrange all of the values when you're going through these things from lowest to largest to keep your work organized and make all of this significantly easier to look at and work with as you're going through this all these processes. Okay. So that is everything for 1.8. And I'll end the recording here, and then I'll take any questions that you guys have, and we'll go from there.